All right, so our talk today is going to be on PostGIS and the data science pipeline. I'll start off just with a little overview of the presentation I've planned for today. So we're going to start off with a bit of an introduction and background about myself and where I work right now. We're going to talk a bit about the role of Postgres and specifically PostGIS as a central component of data science and visualization platform that we're building out. We're going to go over some use cases and examples in data observability and pipeline automation. And we'll have a few slides on data visualization, and we'll highlight and focus in specifically where PostGIS fits into kind of our workflow. And yeah, we'll finish it off with a slide on kind of the role of SQL in our project workflows, and we can have some questions, and I'll jump into the Discord channel after the presentation. Okay, so an introduction, a little bit about me. I've kind of been in the GIS and slash web mapping industry since the early 2000s, both in kind of client-focused consulting firms and large corporations. I did a stint working in enterprise IT and application development support, some automation type work, and then also worked on the business side of the postal and courier industry, doing GIS and data analytics and work in that. Currently, I am working for CPCS in their infrastructure analytics group. I lead up the visualization practice and work on data analytics, sort of a data engineering type role in that. I'm based out of Ottawa, and the next slide, I'll do a quick overview of CPCS, the company I work for. So it's a global management consulting firm, really specializing in three things. So the transportation, power, and public-private partnerships. So we really work globally. We do a lot of work in Africa, US, Canada. We're based out of Ottawa, our head office. And yeah, so we cover the kind of entire project life cycle from analytics to legal, technical, economics in large infrastructure projects. So specifically, kind of the setting I'm in, so it kind of sets the rest of the presentation so we understand where all the PostGIS and technology fits in. So our infrastructure analytics group, so we kind of focus on three things. So data science and analytics, cartography, visualization, so web-based and kind of reporting and hard copy cartographic for reports, and modeling and foresight. So the makeup of the team ranges from highly technical modeling and statistical expertise to really experienced GIS analysts in the transportation and power industry. So doing kind of end-to-end GIS workflows. Yeah, and then some development and people with some kind of cloud computing expertise too. One thing to note is that we're technology agnostic, so we really focus on using the best tool for the job. We use both open source and some commercial off-the-shelf tools. Yeah. So kind of the high-level goals of the talk is we get an understanding of some of the tools and workflows we use for our client project work in infrastructure analytics. And we'll really highlight the areas where Postgres and PostGIS has made a difference and been a really good fit for us. Okay, a little overview on our data science and visualization platform. So some of the key requirements we looked at when we were sitting down visioning this out and working on some prototypes are the first thing, it really had to focus on project-based workflows. We're consultants, so we need to design a system to really optimize this project delivery and client outcomes. So that's first. Automation, so we definitely see a lot of new data sources coming in. So there's a lot of analytical processes within our projects that we're definitely needed to be automated for that. The third one, the innovative data sources. So we're really focused on being kind of front runners in the industries we work in. So whether that's identifying new third-party data providers, prototyping new approaches to run analytical pipelines on that. The other thing with the pipeline was, as far as tooling choice was, it really had to be easy to administer. We wanted minimal configuration, kind of simplified application development. We're not a huge team, so we didn't want to take on a lot of overhead. So a lot of these analytics and tools, there's a lot of configuration and many different components within that. And it really had to be compatible with our existing workflows. So desktop analytical approaches, typical modeling approaches. So we wanted to kind of add on to our toolkit with this platform we're building out. Okay, this slide's kind of a high level, kind of just an overview of the data science and visualization platform. So what we're looking at now is kind of a typical data analytics tool you might see, or sketch you might see at some of the different cloud providers, but they would have probably 30 or 50 different tools for each of these boxes. But we'll do kind of a brief overview starting kind of left to right. In the presentation, I'll go quickly over kind of the, we'll talk about the blue and red boxes in this, the gray ones, we'll leave that for a future. But so starting from the left, that box, the data sources, we're just really representing kind of different internal and external sources of data we use for our project workflow. So this could be third-party API integrations and connections. It could be kind of local public data sources. It could be in-house data sources that we use for different project work. So everything starts with the data. So as we move to the right here, the first data storage box. So what we're representing here is kind of raw data storage, right? Sort of a small data lake type approach if we're using some of the data science lingo. So, large file storage, and even, staging type databases for more extract, transform, load approaches. And then as we move over to the right, the analytical data stores. So this is where, sort of a data warehouse type approach, but when our data gets in here, we really want it to be able to analyze. So it should be cleaned, formatted, sorted, and they're ready for our project teams to really analyze and visualize. And then in the right, the far right blue box, the interactive visualization, analytics, and reporting. So we kind of, on the visualization front, we do everything from interactive web application to visualizations for hard copy reports to kind of web-based data stories, web page design. And the one part I really want to talk about is this bottom workflow and data orchestration, data pipelines one that stretches across this whole platform. So what we're talking about here is, so we'll go into a little bit more detail, but what this is representing is kind of a toolkit and control plane to really transfer and help that data flow throughout this platform. And then on the next slide, I'll kind of highlight where some of the technology choices are and go into more detail in that one. But this is kind of a high level overview. And the bottom right here, application delivery environment, that's highlighting that this is sort of our internal analytics engine. And then we also develop and host applications for external access for clients based on this type of workflow. Anyway, yeah, so the whole goal is to get this analytics stack useful, scalable, and easy to maintain. Yeah, so for the audience that are technical, which I think most of them are here. So we've kind of added in and highlighted the areas where we are currently using Postgres or PostGIS. So the first area is, like I noticed or I mentioned in the previous slide, this is a data storage layer. So the majority of work here is we use an S3 compatible object storage. We're using DigitalOcean Spaces for this, so cloud storage. So this could store, everything from a terabyte of GPS data we get from a data provider or client, to some of our internal data sets that we use widely on different projects and can share out. And then the highlighting of PostGIS Postgres in this box really reflects sort of a staging type database where we could run pipelines through it and do some analytics before it ends up into the kind of more analytical data store that's ready to be queried and visualized and reported on. The bottom area here, so the workflow and data orchestration. So we have highlighted a couple things. So Python is kind of our main language that we code for this specific platform, and it's this is the control plane. We use a tool called Dagster, which is a kind of a data workflow orchestration tool that lets us pretty much at the end of the day, we're writing functions using lots of SQL, lots of the typical data science libraries to go through here and analyze our data as it comes into our database environment. And the interesting thing here is Postgres is kind of our default data storage for this workflow and data orchestration layer that holds metadata. And I'll have some more details on that later. Okay, so why do we have PostGIS as a central component of the platform? So there's a lot of reasons why, but I'm just going to go kind of around this diagram here. So functions, like at the core, we're analytical. We're an analytical team, so the large collection of built-in analytical functions in PostGIS is something you just can't pass up. There's a function in there to analyze pretty much any type of data you need. And if it's not there, some of the extension ecosystem, we can find it there. Familiarity. So our staff and most staff now and recent graduates do have familiarity with either QGIS and usually PostGIS. So most of the staff is familiar with PostGIS. The extension ecosystem, again, if the base install doesn't have what you need, usually there's an extension that'll work out for that. So and it's based on PostgreSQL, right? It's a proven rock solid enterprise database. So that's a huge win, right? Especially for the administration side. We have a lot of mature database clients, so QGIS, pgadmin, this list can kind of go on and on. Really good client libraries. And then the bottom one, so modern data engineering tools. What I mean by that is, so when I highlighted that Dagster data workflow tool, a lot of these tools use Postgres as kind of their backend to store metadata, job run type stuff. So, Dagster's not the only one. There's a few other kind of SQL data modeling tools. So when you kind of dig deep in this, Postgres is, if not the first tutorial you find, the second one, right? So more and more, it's becoming almost default in this data science ecosystem. So another reason we have Postgres and we've chosen it is that, our analytics are kind of hyper focused on the transport and power sectors. And one of the key benefits we found specifically with PostGIS is, the availability of the different data types, right, that we find in both those industries all the time. That allows multi-model data storage and analytics, in a single tool. It's really hard to give up. That's having the analytics and storage in a single tool is really great and really simplifies some of the analytics you work on. So I'm going to go into data observability. And first, so a little bit about our company. We're a pretty tight company. We've recently, you know, just one sec here. Yeah, so on our website, we've released some documentation on the way we work, and the one I want to highlight here that really ties in with the analytics is that we believe that our solutions and advice should be evidence-based. So it really ties into the analytic integrity, which ties into the kind of tooling choice we have throughout our platform. And so data observability, what I really mean by that, so we're talking about a horizontal view of kind of data assets as it travels through that diagram I showed a few slides back, right? So as it travels left from right, you want to know what happened to the data set, what computations were performed on it as it travels through that whole analytics workflow. So a couple of questions that relate to data observability is, when was that last data ingest from that external API provider that we're harvesting data for a project? How do we track the lineage, computational output? What source data was used to create those plots and figures that were included in that deliverable on that date? How do we track and relate metrics like query execution time along with other metadata and output? So at the bottom of this slide, if we go back to that workflow and data orchestration, the note I've highlighted here is that the choice of Postgres really simplifies the whole software stack, because we can get not only the analytics from Postgres and PostGIS, the spatial analytics, by using this workflow and data orchestration pipeline layer that stores everything in Postgres. So we're using one tool to have a unified view of not only our data, but what's happening to our data as we're analyzing it. So for the data pipeline automation, so what I've kind of highlighted here is a typical pipeline. This one is showing, harvesting data from a state truck parking API. And we're showing it as sort of an orchestration graph is what our workflow tool does. And most of the people in the GIS industry are kind of used to viewing data like this. The difference between the Dagster tool we use and a lot of the other ones, it's not a point and click, so it's really code first. The UI that I'll show you on the next slide is really driven by code, specifically Python functions. So if we look at this data pipeline, it's really typical, and you see this lots, right? So we're hitting a few different APIs for different state truck parking data sets. We're appending some metadata, some date time processing. We're saving that raw, in this case, JSON data out to an object storage. And then we're doing some cleaning, transforming, and posting it in PostGIS Postgres a database. And again, some of the pipeline that we're currently working on, sometimes the SQL and Postgres analytics come earlier in the pipeline. Sometimes they come at the end after, but this kind of follows a typical kind of ingest, clean, transform, post it into to a database ready for visualization and analytics. Yeah, so this is a kind of a typical one that we use. We also use it to test, so we have it scheduled running kind of all the time. So so we can test everything from software and database upgrades to see if it works. So we have a few kind of development versions running on that. Some of the more advanced pipelines that we're working on with kind of larger data sets. So we do a lot of freight studies with GPS trip and waypoint analytics, and kind of deep dives in origin destination analysis. And then the marine AIS kind of data architecture analytics for port authorities. So what I have here is we're going to watch a quick kind of video of the Dagster tool, and it's really a lot of these boxes are functions that interact with databases, right? So at the end of the day, a lot of it is just sending SQL back. So what we can see is we can zoom in and really get a view of all our data. So as we switch tabs here, we can see configuration, we can manage different configuration, we can see the history of runs. So this is a pipeline run, so we see the complete history, and we can drill down to each run. So we see green here, so yep, these are good. So red is bad. We can drill into specific runs, and we see all the different functions highlighted in here, and we can get the log data all in one view. So it's really nice to deep dive. This one doesn't have a ton of SQL, but some of them that do more advanced analytics, you can really do a deep dive into it's any troubleshooting, or really if you're noticing difference in query time, execution, stuff like that. I'm just gonna go back here. Watch this again. So as we zoomed in, you get more details as you zoom in as how the data flows through that pipeline. Right. The other thing is that we can attach schedules. So this is an example of one that we test out every half hour or so. And then the partition. So you'll see this is also all this metadata is stored in Postgres. So it's nice. It gives a detailed view of each part of that pipeline. The green means it was successful across the states. You get that longitudinal history of last 30 days. You get different execution times. So you get that deep visibility into our analytics. So that's just a quick overview of the pipeline. And again, most of that analytics is touching PostGIS and Postgres. The next slide here, where we see PostGIS and Postgres pop up, is in our data visualization work. So we kind of run the gamut on different data visualizations, like I mentioned before. So at the top, we will do sort of the Python data, dashboarding framework tools. So we have multiple linked views. Again, for the most of these, there's Postgres, PostGIS, either GeoJSON or vector tiles behind these, and also for the time series and all data, right? So basic standard SQL queries driving with a minimal layer on top driving a lot of these. So yeah, we do web page design with embedded web maps and infographics, and a lot of this stuff's data driven from databases. If the data volume allows, typical kind of GIS in the browser web mapping that's driven by tiles and features, and some more standard kind of web-based data viz type work, and so PostGIS and Postgres both drive that, along with if needed, we do put on, we'll use PG feature serve and tile serve, the kind of crunchy data microservices on top of that. So the applications kind of flow into our application delivery environment. So after we analyze the data, and if we have kind of client-facing tools that we want to put up, we also have we've built out a hosting infrastructure, and Postgres and PostGIS plays a big part in our actual applications for our clients. So I've highlighted a few. These kind of components change. We're pretty nimble on what components we use in applications. But if I start on the left here, we have a hosting environment that we set up. So we're kind of using some of the cloud native technologies. So we have a reverse proxy coming in. We use Docker to kind of containerize our applications when it makes sense. Our reverse proxy will manage the important parts like security and routing to different applications. So by using kind of Docker and Docker Compose, we can really bundle up and package up our application. So this sketch shows Postgres bundled up. We don't always do that, but sometimes if it's just a read-only data visualization type, we can kind of bundle it right up into a package. But we also have sort of a multi-tenant Postgres install for any common data between applications and data like that. So we develop and host a typical web app. We would have PostGIS as the back end, and sometimes Redis. This could switch out. We could replace this with PG Feature Serve or TileServe too. Again, we kind of have configurations to spin these up. And a typical dashboard app might be a Python kind of Plotly dash framework app that queries PostGIS and Redis maybe for caching, and the right one just represents maybe some external API calls. But yeah, so that's our cloud application. And then the kind of last thing I wanted to talk about is sort of the importance that SQL plays in this whole end-to-end kind of data analytics and platforming workflow. So we do use a variety of tools. Like I said at the beginning, we kind of choose the best tool for the job. But when it really comes down to it, the commonality between all those is the use of SQL, right? And treating that as kind of a first-class citizen in the analytics workflow by using source control, versioning, that helps us in our reuse and reproducibility. So no matter what tool, this isn't all the tools we use, but at the end of the day, a lot of them turn out to be database clients issuing SQL back and forth, and there's a lot to gain by really utilizing SQL throughout not only data visualization, but you'll see in our data pipelining tool, a lot of this code can be reused throughout this stack, right? Which is really nice to quickly develop applications and prototype applications and get them in front of the clients at the end of the day. Thanks. That's the end of the presentation. So if there's any questions, I can take those now, or I can jump into the Discord chat for kind of the next few hours tonight.
Well, so we definitely got one question from an anonymous attendee. Well, thanks for the talk. That was awesome. I really liked it. I also liked the Canadian accent. It was good to establish where you're from. Do you use SageMaker? Is what the person wanted to know.
No.
Okay, that was a simple one. 2 letters. Yeah. All done. So are you using? I forget what the Daggert or whatever. Is that what you're using to replace SageMaker, or?
I'm not familiar with SageMaker, but Dagster is our kind of data workflow pipelining tool that we use. Yeah.
Okay, so that's almost like FME. Is that right?
Yeah, I guess they're both kind of what do you call them, DAG-based workflow. Yeah, the kind of difference is that it's really code first, so it's not a point and click UI. It's code first. It allows us to not only develop in Python, but run jobs in different execution environments. So we could fire SQL to a database, or if we go to more of the data science, if you need to run analytics in Spark cluster or any of the other more computational environments. So the pipelines can set up to run in different execution environments, which we found nice. And that UI is a big win, right? Getting that visibility into that data workflow.
Right, like you can actually see what workflow you've orchestrated. Like it's good to have code. Can you put that? Could you actually version that code? Can you put it in GitHub and stuff like that?
Or sure, yeah, it's just code, right?
Okay.
So yeah, it's just raw Python code that Dagster, and when it's issuing SQL, it's basically the smallest lightweight kind of function wrapper around some SQL code.
Okay.
So it's like a decorated function. Yeah.
That's really great. And I mean, I think another nice thing about your example that you used is proving one of the points that I think it was Paul said earlier, was like having all your data centralized in the PostGIS database allows multiple clients to hit the same authoritative data, right?
For
It's not
sure.
like, well, I've got this shapefile here, and then we export it to a different shapefile over here, and then we do this over. It's like, no, the data moves through the databases in a code executed pipeline. Like there's very few manual steps once the pipeline is set up. It seems like there's almost none.
Yeah,
And
for sure. And again, right, that like this slide that we're looking at now, the SQL can be shared or between a lot of these clients, right? So
yeah,
you can use the same SQL and QGIS as you're using a Jupyter notebook to query your PostGIS install.
okay. And then there's one question online, but I had another question about this. But now again, I have forgotten because I was trying to balance too many things in my head at the same time. So we'll go to the question here and maybe I'll remember. Alexander asks, what database instance type do you use on AWS? How did you optimize it for PostGIS? Do you have different instance types for real-time or batch processing?
Yeah. So I'll talk about the first one. So we don't use AWS. We use DigitalOcean. We manage the Postgres. So a lot of the cloud providers we found, lag too far behind on some of the extensions and things like that. So we use our own install in our DigitalOcean cloud environment for that.
Okay, and actually, while we're going here, we're getting a bunch more questions. So,
So what I can hop over.
no, I think we have time.
To the,
Hold on.
yeah.
I think we have time. What time is our next talk? Because I like hearing the voice in the back, a little bit of the back and forth. I really enjoy that. So what time is our next talk? You just did this one. It's at 4:30. Oh, are we done? We're done, aren't we? Oh no, we have a few minutes. He doesn't start until 4:45. Never mind. That always freaks me out. I can't remember that I give us more. So are you okay with answering them here?
Yeah, sure.
Okay.
Yeah.
So what was the other? Oh, they were in chat. Can you provide more details about the web application stack?
Sure. Yeah, I guess there's key components. So some of the let's see if I go back there. They're not the best diagram, but yeah, because we really work with spatial data in almost all our projects, right? We always try to use PostGIS. If it's just a small data set, we can even drop down to static ones. But for PostGIS, we use that. The Redis or other component there is kind of a caching layer if we need it, and that's more for some of the dashboard type apps. It helps with that depending on how they're configured.
Right.
And again, Docker we find nice to bundle up applications. Even mostly Postgres isn't always in there, but it can be. And then with our it workflows nice in our hosting environment because with some of the tools and the Docker networking, we can really control what's available externally and internally and manage it that way.
Right. And so then with the Nginx, are you and that's just serving up static pages. Are you using Python to do your web? Are you using Django, Python, Java, Node? What are you using? Do you know what you're using for most of your web serving?
Yes, so I would say Python within with some of the dashboard ones, but I guess an interesting thing in the Nginx, it's we use a bundled one called OpenResty, which has a scripting interface. So not only do we use it sometimes as a reverse proxy and cache, which is kind of a pro tip, especially if you have some of the tile caches and feature servers on there. It's having a nice scriptable reverse proxy in front of that, it always makes the application kind of easier to maintain. And again, within the Nginx, we can actually talk to databases and
Right.
yeah, reverse proxy out to HTTP and stuff like that. So
That's cool.
so it's kind of a custom bundle of Nginx. So
okay, cool. How do you handle sparse or dirty data sources?
I guess that comes out. I should talk kind of more about, so the typical workflow, right? So when we're looking at this kind of cloud-based data pipelines through there,
Mhm.
that's not how things start, right? So you would start local development, so that kind of workflow Dagster tool that I was showing, it's geared towards local development first, right? So you would test out your pipeline, you would write all your code, get it ready for I guess production environment, and then publish it up there, right? When it's right, when it's ready. And again, data is not always perfect, and that's where all that observability and metadata for the job runs. And one other thing I didn't really show is the ability to kind of archive assets. So whether it be generating charts and graphs at every stage of that pipeline, or maps that you can go back to and troubleshoot any data issues if there are any. So,
Okay, cool.
yeah.
Another one was, to what degree does PostgreSQL databases drive the cost in your cloud-based pipeline? So you're using
Oh, yeah. So,
DigitalOcean's Postgres's. Like, how much
yeah.
does that actually drive the cost of what you're doing?
Yeah, again, this thing is kind of incremental, so we're not talking massive data flowing through this, right? So again, if I go back, we're working kind of project based workflows, so we don't have like tons of continuous data, so there's not much of a cost at all between um, the environments, based on getting a kind of a big enough machine to
To host it.
to host.
Okay.
And again, with the combination of um, kind of object storage, so S3 or S3 compatible object storage with a database like PostGIS is
Right. So
nice, right?
you
Yeah.
use the database to point to the object stores. Is that what you do?
Well, there's kind of a layer in between, right?
Okay.
That so some data can stay in the object store, but yeah, and transfer back and forth.
Okay. Well, I think we can take the rest of the questions in the chat, because I want to leave people at least 5 minutes between sessions. Brent,
Yeah.
that was, I mean, oh, I kind of remember the question. I mean, how did you come to this data sourcing pipeline? Like, this is actually, you see, this isn't typical to see in a GIS company, at least from what I've heard,
No,
right?
no. I think I was introduced to working in kind of an enterprise uh, IT environment,
Okay.
included some GIS, but not all that. And when you like the last 5 years, there's been a push in the enterprise moving from a lot of the legacy BI data warehousing space into some of this more workflow type tools.
Right. And
So
it's all automated and it just kind of goes, right? Like,
yeah, so there's kind of a lot to, in my mind, it's sometimes good to look outside the geospatial industry. There's some good matches here, right? Especially when you're using standard tools like SQL.
right, exactly. I mean, that's one of the nice part about being Postgres and PostGIS, right? It's,
Yeah,
there's not some weird interface that you have to start using different kind of objects. It's just SQL calls. And so,
yeah, yeah, for sure.
okay. Well, thanks, Brent. That was really great.
All right,
All right.
take care, and thanks for having me.